Hey guys, so today we're going to take a look at compound inequalities. And just like compound words, our compound words are like cupcake. You're putting cup and cake together to make one word. A compound inequality is just going to be two inequalities put together. And we're going to always join them with one of two words, either the word and or the word or. We're going to save, there's something on here called interval notation. And you'll see that at each spot. We're going to save that for when I'm with you to go over. So we're just going to ignore that part for right now. All right, so a compound inequality is two inequalities. Oh, I don't want to use red. So two inequalities joined together with and or. And so we're going to talk about each one of these situations. I'm not going to put anything right there, so I'm just going to cross that off. All right, so let's just talk first what the word or means in math. The word or in math means that I'll take this or I'll take that and I don't care. So we're looking at solution sets that include really anything from two different sets. So what I mean by that is if we have, let's take something in real terms. If you have two different sets of things and they have some, maybe they have an overlap, maybe they don't, and we're dealing with an or inequality, we're going to take everything from this first set A, we're going to take everything from set B, and we'll take everything that they have in common. And so an or is a situation where we take everything that they have, that they offer. So let me show you what that means. If I care about all the numbers that are less than or equal to -2 or greater than 3, I'm going to graph both of these on my number line. Because I have the or equal to, I put a filled in circle. It's less than, so it's all the values less than. So that's this guy. X is less than or equal to -2. X is also greater than 3. And so if I asked you for a number that was true for this situation, you could give me a number from either one of these sets and that would be true. So you could say -5, that would work because that's less than -2. You could say 8 and I would say, yep, that works because that's greater than 3. So as long as it's in one of these two solutions, this solution or that solution, it is a solution to this inequality. So let's take a look at what that looks like in solving inequalities. Notice these are all ors. I'll show you what the and one looks like next. And so when we solve these, we're going to go ahead and just solve two different inequalities as if they're two separate inequalities altogether. So I'm going to start off by solving the one on the left. I'm going to add 4 to both sides. And I get x is less than -3. I come over here, I put an open circle on -3, and I go to the left. Now I'm going to go ahead and solve this equation. I need to get x by itself, so I divide each side by 2. I get x is greater than or equal to 6. So I go over to 6, I put a filled in circle, and I go to the right. So my solution is x is less than -3 or x is greater than or equal to 6. And so again, if I said, what is a value that is true for this inequality? We could say -8, that would work. We could say 8, that would also work. The only numbers we couldn't say are the numbers between -3, including -3, and 6, but not including 6. So if I said 0, that would not be a solution to this inequality because it's not within my solution set. Let's try another one. So we have an or. My final answer is going to have an or in between my two inequalities. I'm going to start off on this left side. I'm going to divide by -3. I have a situation where I'm dividing both sides by -3, so I need to switch my inequality sign. A negative divided by a negative is a positive, so I get x greater than or equal to 3. So that guy's all set. Now I'm going to subtract 5 from either side. I get x is less than 1. And now I'm going to graph both of these. So x greater than or equal to 3, I'm going to go to 3, put a closed in circle, and go to the right. X is less than 1. I'm going to go to 1. I'm going to put an open circle because I don't have an or equal to, and I'm going to go to the left. And I'm all set. All right, I want you to try the next. I'm going to leave these two open. You're going to go back and do those on your own and then check your answers. We're going to go ahead and do this one together because it goes over a couple things that I want to take a look at. So we're going to start by distributing that negative 3. So we get a negative 6x, subtract 3 is less than negative 15. Now again, I'm just solving it like we solve those equations. I add 3 to both sides. I have negative 6x is less than negative 12. And then I'm dividing both sides by negative 6. Again, I went ahead and I divided both sides by a negative. So I need to switch my inequality sign. So I get x is greater than 2. Or, now on this one, I'm going to subtract 1 from each side. And now be careful, I have a negative x that I need to bring down. So I have negative x is greater than or equal to 4. And now we have a little 1 hiding in there. I'm going to divide both sides by negative 1. And when I divide by a negative, I need to switch my inequality sign. So we have x is less than or equal to negative 4. And x is greater than 2. All right, so those are our OR inequalities. You're now going to do some practice on those on Delta Math before you try some AND inequalities.